And now let's see how the median can be calculated for the group data. So how we can find the middle value in the group data. So the first element is xm, which is the lower boundary of the median group. And now the question is how to determine the median group. And it's actually quite easy. So you need to think which observation, so the number of this observation that splits your sample into two equal samples. So for example, in our case, we've got 25 students. So student number 12 and student number 13, those are the two middle values. So we need to look for the group where this student number 12 and student number 13 are. So the first group has only 5 first students, so definitely number 12 and number 13 is not there. And then if we look in the second group, it will be right there because the second and the first group together give us 15 observations. So number 12 and number 13 will be in the second group, which means that group number 2 is the median class. And we can see that the lower boundary in this class is 35. So that's the first value for the equation. Then we move to this fraction. So n is the total number of observations, which we know is 25, which we'll divide by 2 and subtract fm, which is the cumulative frequency before the median group class. So we've established that the median group is number 2, which means that the group before it is number 1, and the cumulative frequency within this group is just 5. After this, we divide by nm, which is the number of observations within the median group. So number 2 is the median group, so we can see that the number of observations within this group is 10. So the difference must be divided by 10, and after this we multiply this fraction by the median group width. And this value is calculated as the difference between the upper and the lower boundaries. So in our case, this will be 55 minus 35, which gives us 20. So the fraction should be multiplied by 20. So we get that the median for this group data is 50. As for the mode, this is the formula. And for this formula, we'll also need a couple of elements. So first we need xm0, which is the lower boundary of the mode group class. So now we need to determine the mode group, and it's also quite easy. This is the group that has the highest number of observations. So if we look at our into our table, we will see that the class, the group that has the highest number of observations, is actually number 2. So the mode group and the median group are in this case the same. Okay, so we know that the mode group is number 2. The lower boundary, we remember it's 35. Then we put a plus and we write down this fraction. So the first element is nm0, which is the number of observations within the mode group. We remember we've got 10 observations within this group. Then we subtract nm0 minus 1, which is the number of observations within the group before the mode group. So this would be the number of observations from the first group, and in our case this is number 5. And then we divide it by the same difference plus, once again, the number of observations within the mode group. So 10 minus nm0 plus 1, which is the number of observations within the group after the mode group. So the group that we have after the mode group is number 3, and we can see that the number of observations there is 6. And after this fraction is once again divided by the mode group width, which we know is the difference between the lower and the upper boundary. So it is equal to 20. So when we put everything into one equation, we get that the mode for this data set is equal to 46.11.